Have you ever been handed a messy data file and just had no idea where to even begin? Well, today we're going to fix that. We're going to build a really clear step-by-step workflow in Pandas. The goal here is simple. Take those raw files, the Excel sheets and JSON data we see all the time, and transform them into clean, reliable assets that are ready for whatever analysis we want to throw at them.
So this whole process, it really breaks down into 4 simple but super powerful stages. First, we load the data. Then, we put on our detective hats and inspect it to figure out exactly what we're dealing with. After that comes the most important part, cleaning it all up. And finally, and this is key, we save our clean data so we never ever have to go through that same cleaning process again. It's a simple, repeatable system that will save you so much time.
Okay, here's our game plan for today. We'll start with the big picture idea of the workflow, then we'll dive right into the practical stuff, reading, cleaning, and saving our data. To wrap up, we'll talk about why this whole process is so fundamental to good data science.
All right, first things first. Why even bother with a structured workflow? I mean, why not just jump in and start cleaning things as we find them? Let's talk about why that's usually not the best idea.
Here is the absolute key takeaway. A data workflow isn't just a to-do list. Think of it more like a recipe. It makes sure that every single time we process our data, the result is consistent, it's predictable, and it's reliable. And that means we can actually trust the data sets we build for all of our future analyses or machine learning models.
Okay, time to get our hands dirty with step 1, loading the data. We're going to focus on 2 formats that you will see absolutely everywhere, the classic Excel spreadsheet and the JSON files that are basically the lifeblood of modern web APIs.
Reading a standard Excel file is wonderfully straightforward with pd.readExcel. But there's a little gotcha you need to know about. For the modern .xlsx format, Pandas needs a little helper library. You'll probably need to install something called OpenPyXL. Just a quick pip install OpenPyXL in your terminal, and you'll be good to go.
Now here's something that's really powerful. Pandas can actually ingest an entire Excel workbook all at once. If you set the sheet name parameter to none, you don't just get one sheet, you get back a Python dictionary where each key is the name of a worksheet and its value is a complete data frame of that sheet's data. It is incredibly efficient.
JSON is the other beast you'll be taming all the time, especially if you're pulling data from the web. Reading it is just as simple with pd.readJSON. The twist, though, is that unlike a neat spreadsheet, JSON can be structured in a whole bunch of different ways. And this is where the orient parameter becomes your absolute best friend for getting the data in correctly.
So what does orient actually do? Well, you can think of it as your personal translator. It tells Pandas how to read the JSON, is it a list of records, a dictionary of columns, and then how to map that structure into the flat, two-dimensional world of a data frame. Getting this one parameter right is absolutely key.
And this slide breaks down the 2 main orientations you'll see most often. On the left, orient equals records is super common for API responses. It's basically expecting a list where each little dictionary inside that list represents one row. In contrast, the default orient equals columns expects a dictionary where each key is a column name with all its values nested inside. 2 very different structures.
All right, the data is officially in our notebook. Now comes the real work, the transformation stage. This is where we play detective, find all the little problems lurking in our data, and methodically clean everything up so it's actually ready for analysis.
These 4 commands right here are your first-line diagnostic tools. .head gives you a quick peek at the first few rows just to see what you're looking at. .info gives you a fantastic technical summary of your data types and counts of non-missing values. .shape is simple. It just tells you how many rows and columns you have. And my personal favorite, .isNull.sum, which instantly counts up all the missing values in every single column. So useful.
Now here's a crucial cleaning step that people often skip: standardizing your column names. This chain of string methods is an incredibly powerful one-liner. It strips any pesky white space from the beginning or end, converts everything to lowercase, and replaces spaces with underscores. Doing this makes your columns so much easier and more predictable to work with later on. When you find missing values, you really have 2 main choices. On one hand, drop NA is the quick fix. It just removes any row or column with missing data. It's simple, but be careful, you might be throwing away really important information. On the other hand, fill NA is a more thoughtful approach. It preserves your data by filling in a value. This is often the better route, but you have to think carefully about what you fill it with, or you could accidentally introduce bias into your dataset.
Finally, you have to make sure your columns have the correct data type. I mean, you can't calculate the average of a score column if it's stored as text, right? The pd.toNumeric function handles this beautifully, and that little argument, errors equals coerce, is your safety net. It will gracefully turn any values that just can't be converted into numbers into NaN, or missing values, which you can then decide how to handle.
Okay, deep breath. We've loaded, inspected, and cleaned our data. We're on the home stretch now. It's time to save our masterpiece, creating a pristine data set that we can reuse anytime we want without having to repeat all of this hard work.
So the toCSV method is pretty much the standard way to export your work into a format that anything can read. This simple one-line command will save your beautiful, clean data frame. But this simplicity hides a very common pitfall that trips up almost everyone when they're starting out.
So you run the command, you open the CSV file in Excel or Google Sheets, and what's this? There's an extra, unnamed column at the very beginning that you know wasn't in your data frame. What's going on? Well, that's the data frame's index, which Pandas has helpfully decided to write out for you.
So the big question is, why does Pandas even do this by default? And more importantly, how do we stop it from cluttering up our perfectly clean data set every single time we save it?
And the solution, thankfully, is this one simple but absolutely critical parameter: index equals false. By adding this little argument, you're explicitly telling Pandas, hey, do not write the index into the file. Honestly, this is the command you should probably be using 99% of the time you save a CSV. Just make it a habit.
But what if you need to share a few related datasets? Well, instead of sending a bunch of different files, you can use the Excel Writer object to neatly package several data frames into separate sheets, all inside a single .xlsx workbook. It's a really clean and professional way to deliver your results.
So let's just take a step back for a second and think about what we've really accomplished here. Why was this entire workflow so important? The real payoff, the big win from this entire process, is that you've moved beyond just writing one-off exploratory scripts. You've built a reliable, clean asset. This file can now be the trusted starting point for any future analysis, for any visualization, for any model, which ensures your work is always consistent and repeatable.
And that really brings us to the end of the cleaning process. But it's just the beginning of your data story. You've done the hard, foundational work. Now the really exciting part begins. With this clean, reusable dataset in hand, what new insights and what new stories are you going to uncover?